If you want to choose a more efficient blower, you may think of the recently popular maglev turbo blower and airfoil bearing turbo blowers, which look like twins but are actually different. What exactly are the differences between them? Let's take you a look and find out the truth. FGAMB maglev turbo blower adopts the most advanced active magnetic bearing and AMB controller, which is a kind of new typical mechatronics bearing system. Radial bearings control the radial position of the rotor, and axial bearings control the axial position of the rotor. Position sensors detect the rotor offset in the XYZ direction in real time. Speed sensor detects the rotating speed of shaft. AMB controller monitors the magnetic forces of AMB bearings and shaft running state automatically. The magnetic force is generated from the permanent magnet synchronous motor. The rotor is driven to rotate only after suspended stably by the electromagnetic field. There is no contact between the rotor and bearings during blowers stopped or running, so the bearings and motor are well protected. This kind of technology can realize truly frictionless start of the rotor without lubrication. Equipped with accurate controlling system including active magnetic bearing controller, active magnetic bearing, sensors, PLC, inverter, HMI. Users can monitor the running state of the rotor in real time according to their own needs, such as its position, offset, speed, and direction, ensuring the safe rotation in a controllable state, and solve the mechanical friction, physical wear, lubricating oil, bearing or motor replacement and other pain points of traditional bearings, and avoid the risk of non-active control factors of air suspension bearing. As long as the maglev blower is used correctly, the maglev bearing can serve the user for 20 years or more. Next, we go to see how the airfoil bearing turbo blower work. Airfoil bearing turbo blower does not contain bearing controller and bearing sensors. After the motor is energized, the suspension of the rotor is driven by the high-speed rotating impeller suctioning air from the atmosphere and generating the airflow. The radial airfoil bearings generate the air film supporting rotor, and the axial airfoil bearing forms the radial airflow driving the rotor forward and backward. It's called air dynamic pressure effect. When the blower is not energized, the mating surfaces of airfoil bearings and rotor are in direct contact. In the early startup of blower, because the high-pressure air film has not reached a stable level, the airfoil bearing will face the inevitable low-speed dry friction problem. Only after the rotating speed reaches 3000 rpm to 5000 rpm, a high layer of pressure film is built around the center of turbine to promote the rotor's suspending and rotating stably. When the blower slows down to stop, the pressure difference generated by the air bearing is getting weaker and cannot support the rotor always. The rotor falls and hit the bearing, causing sliding friction until stopped. After frequent starts and stops caused air bearings wear, the equilibrium of the fluid system is disturbed, the probability of one-time startup success decreases, user may need to restart several times till successfully. The motor and bearing are easily broken due to repeated startup and stop. This kind of blower is lack of active control system. In practice, it is difficult to exclude the change of atmospheric environment brought by uncontrollable risks. User may have to replace the airfoil bearing after 3 to 5 years. Due to the hardware and software characteristics of maglev turbo blower, its structural and systematic advantages can be more intuitive and higher technical content, mainly reflected in the following advantages. First, controllability. Maglev turbo blower is equipped with active magnetic bearing controller and position and speed sensors that allows users to adjust the running state of the blower rotor on demand. The airfoil bearing turbo blower lacks a bearing controller and sensors module that not allows users to adjust the rotating status of rotor. Its suspension only relies on the rotation of impeller and rotor to build the air film, which means airfoil bearing turbo blower cannot be completely controllable. Second, adaptability. The clearance between the rotor and the bearing of the maglev blower is 400 micrometers to 600 micrometers, so maglev turbo blower can be used in the high temperature or harsh industrial environments. Bearings and rotor do not have mechanical wear problems. The clearance of the airfoil bearing turbo blower is only 10 micrometers. There are critical requirements for air cleanliness in its working environment. In the harsh environments, the even fine dust is easy to attach to the bearing and rotor surface. It will destroy the fluid balance system and cause broken of the motor and air bearing. Third, lifespan. About the service life of bearings, the rotor and active magnetic bearings of maglev turbo blower are always free from mechanical contact and mechanical wear during operation and rest, so the bearing's lifespan is more than can achieve 20 years or above. While the rotor and bearings of the airfoil bearing turbo blower cannot avoid the mechanical wear during machine start and stop, the service life of the bearing's lifespan is about 3 to 10 years maximum, and the core parts need to be repaired or replaced after 3 to 5 years. Fourth, safety. Maglev turbo blower is equipped with power failure protection and auxiliary bearing protection devices. A power failure protection system can be fulfilled through the DC-DC automatic generating power or UPS uninterrupted power supply to provide buffer time deal with sudden power failure. After the backup power fully cut off, the auxiliary bearings can support the rotor to protect the motor. The airfoil bearing turbo blower does not contain the power failure protection system. Once the power failed, the rotor running in high-speed rotating will fall off, and impacts the airfoil bearing and motor directly. It will cause serious damage to the core components, and the equipment needs to be overhauled. Fifth, impact resistance. The rotor of maglev turbo blower is always controlled by magnetic force in the energized state, so the impact load resistance is strong enough to keep it safety. When the airfoil bearing turbo blower encounters the sudden change of external load, the suspension of the rotating shaft is not stable and cannot be fully controlled. The motor will be easy to burn out. Sixth, variable speed range. Maglev turbo blower is allowed to change rotating speed between 0% to 100%. Airfoil bearing turbo blower's speed need to be controlled within 40% to 100% because of its aerodynamic power working principle. Seventh, after-sales cost. The main motor of maglev turbo blower is safe and stable. In the proper use of blower, user only need to replace the intake filters regularly, so the overall after-sales cost is low. However, the cost of airfoil bearing turbo blower will be higher. Once its motor breaks down, the maintenance cost will be approximate about 60% of another new equipment.